Hello, everybody. In today's lesson, lesson 4.3, we're going to work with dividing mixed numbers. We're on page 91 of the 6th grade Go Math textbook for middle school. And so let's look at the Explore activity. So modeling mixed number division. Antoine's making sushi rolls. He has 2.5 cups of rice and we'll use 1/4 cup of rice for each sushi roll. How many sushi rolls can he make? Well, we can use a model to show that. Okay, so we can ask ourselves how many fourths are in 2.5. Okay, so we have 2.5. That's the number of cups of rice he has. And we're going to break each of these into fourths. Well, we know that there's 4/4 in every whole. So we have 4/4, 4/4, and then 1/2 is made up of 2/4. So how many fourths are in 2.5? 2, 4, 6, 8, 10. So we can make 10 sushi rolls. Which mathematical operation could you use to find the number of sushi rolls that Antoine can make? Well, if you give me a total and I have to divide it by 1/4, we would be using division. We're dividing the total amount of rice by the amount needed for each sushi roll. Okay, so which operation will we be using? We'll be using division. We're dividing the total amount of rice by the amount of rice needed for each sushi roll. So what would the division problem be that was shown by our problem? Well, we had 2.5, and we're dividing the total by 1/4 cups. All right, so what if, number 3, what if instead of 1/4 cups, he uses 1/8 cup? Well, we know that by comparing these, that the eighths are smaller than fourths. In fact, it takes 2 1/8 to equal 1 1/4. So how would the model change? Well, we would have twice as many equal parts. Right? So if it takes 2 1/8 to equal 1/4, well, if we had 10 1/4, we would just double that for 1/8. So we'd have to divide the model into 1/8 pieces. So there would be a total of 20 parts or pieces. Okay. Again, we can show it like this. So if we have 1/4 piece, right, we'd have to break every 1/4 into 2 1/8. And so we had 10 1/4. So 10 times 2, 20. All right, let's look at page 92. Okay, so using reciprocals to divide mixed numbers. So we can dividing by a fraction is equivalent to multiplying by its reciprocal. And you can use this fact to divide mixed numbers. So first, you would rewrite the mixed numbers as fractions greater than 1, and then we'd multiply the dividend by the reciprocal of the divisor. So let's look at example 1. So we have one serving of Harold's favorite cereal contained 1 and 2/5 ounces. How many servings are in a 17.5 ounce box? So we're trying to share the 17.5 ounce box by 1 and 2/5 ounce servings. So our division problem would be 17.5 divided by 1 and 2/5. All right, so step one, so we want to first change each of these mixed numbers into fractions greater than 1. Well, 17 2/2 is 34, plus the extra 1/2 is 35 halves. And remember, we can find that by going 2 times 17, 34, plus the 1 left over, 35, over 2. In this case, we have one set of 5/5 plus 2/5, which is 7/5. 5 times 1 is 5, plus 2 more is 7. All right, so 35 halves divided by 7/5. Well, we can rewrite the problem as multiplication using the reciprocal of the divisor. Use the reciprocal of the divisor. So 7/5. So the reciprocal of 7/5 is 5/7. What would we have to multiply 7/5 by to get a value of 1? Well, 5/7. All right, so then we have 35 halves times 5/7. They're showing us that we can simplify by dividing 35 and 7 by the greatest common factor, 7. So we have left with 5 halves times 5, basically. And 5 times 5 is 25 over 2. And then we can change that back into a mixed number, and it would be 12.5 servings of cereal in the box. All right. So explain how you can check the answer. How could we check that this answer of 12.5 is correct? Well, it's the same way that we would check any division problem. You take the quotient, 12.5 in this case, multiply by the divisor, and you should get the dividend. So in this case, we're multiplying by the number of servings, 12.5, by the size of the servings, 1 and 2/5, and that should give us the amount of ounces in the box. Okay. So multiply the number of servings, which in this case is the quotient, by the size of the servings, which was the divisor, and it should equal the number of ounces in the box, or the dividend. Okay. So in other words, quotient times divisor equals dividend. All right, number 5. What if Harold serves himself 1.5 ounces servings of cereal each morning? How many servings does he get from a box of his favorite cereal? Okay, so we're going to use 1.5 servings instead. So we're still using 17.5 as the size of his favorite cereal. But this time we're going to divide by 1 and 1/2. So we already know 17 halves is the same as 35 halves. 1 1/2. Well, that's one set of 2 halves plus the extra 1/2. So 3 halves. Okay, this is the same as multiplying 35 halves by the reciprocal of 3 halves. Okay, well, we see we can simplify the 2's. And 3 is not a factor of 35, so we're left with 35 thirds. Let's turn that back into a mixed number. Okay, I can get 1 3 from 3, bring down the 5, and we're left with 2. So he can get 11 and 2/3 servings. All right, let's look at page 93. Number 6. Sheila has 10.5 pounds of potato salad. She wants to divide the potato salad into containers, each of which holds 1 1/4 pounds. How many containers does she need? So we're taking this 10.5 pounds and we're putting them in 1 1/4 pounds containers. So our division problem is 10.5 divided by 1 1/4. Well, 10 sets of 2 halves is 20, plus the leftover one is 21 halves, divided by 5 fourths. Okay, 4 times 1 is 4, plus the leftover 1/4, 5 fourths. So we would go 21 halves times the reciprocal of 5 fourths. We can see that there will be a common factor of 2 in 2 and 4. And now we can just multiply straight across. 2 times 21 is 42. And 5 times 1 is 5. If we divide that out, we'd be left with a remainder of 2. So 8 and 2/5. So how many containers will she need? Well, she's not going to use 2/5 of a container, right? So she will need 9 containers. So again, there's 8 and 2/5 containers needed. But if all the containers hold 1 1/4 pounds, she's going to actually just need an extra container, a full container. All right, solving problems involving area. Well, you'll recall that area is the length times the width, right? So if you know the area and only one dimension, you can divide the area by the known dimension to find the other dimension. So for example, the area of a rectangular box is 56 and 2/3 square feet. The length is 8.5 feet. What's the width? So if we take the area and divide by one of the dimensions, it'll give us the missing dimension. So 56 and 2/3 is the same as 170 over 3. Okay, 3 times 56 is 168, plus the extra 2/3, 170, divided by the length of the box, which is 8 times 2 plus 1, 17 halves. We're going to multiply 170 thirds by 2 17ths, which is the reciprocal of 17 halves. All right, well, 17 is a common factor of 170 and 17. So we can divide by 17 and reduce 170 to 10. And we can reduce the 17 to 1. So now 10 times 2 is 20. 3 times 1 is 3. So we get 20 thirds. If we divide that out and turn it back into a mixed number, we get 6 and 2/3. Okay, so the width of the sandbox is 6 and 2/3 feet. All right, so how can you determine if your answer is reasonable? Okay, well, we could kind of estimate, right? 56 and 2/3, that's close to 56, right? If one of the dimensions is 8, then the other dimension has to be 7 because 8 times 7 is 56. Well, our answer was 6 and 2/3. Well, that's pretty close to 7, right? Okay, so again, all we're doing is basically rounding to the nearest whole number here, or the something that would be a multiple of 8, basically, in this case. So 8 times 7. And then we're looking at 6 and 2/3, right? That was our answer, which is close to 7. So the answer is reasonable. Okay, let's move on to page 94. All right, the area of a rectangular patio is 12 and 3/8 square meters. The width is 2 and 3/4 meters. What is the length? Okay, so recall, area equals length times width. Well, they're giving us the area of 12 and 3/8, and they gave us a width of 2 and 3/4. So we have to find the length. Well, I know that if I take 12 and 3/8, the area, and divide by one of the dimensions, it'll give me the other dimension. So I'm going to take 12 and 3/8, and I'm going to divide by 2 and 3/4. Okay, so 12 times 8 is 96, plus 3 more is 99 eighths. And 2 times 4 is 8, plus 3 more is 11 fourths. So multiply 99 eighths by the reciprocal of 11 fourths, 4 elevenths. Well, 4 is a common factor of 4 and 8, so you can simplify that by dividing by 4. And 11 is also a common factor of 99, so divide by 11. So we're left with 9 halves. Well, 9 divided by 2 is 4 and 1/2. So 4.5 meters. All right, number 9. The area of a rectangular rug is 14 and 1/12 square yards, and the length is 4 1/3 yards. What's the width? Same procedure, right? So we're going to take 14 and 1/12. I'm going to divide by the dimension that we know, the length. And that will give us the width. So 14 times 12, 168, plus the leftover 1/12, 169 twelfths. Divide by 4 times 3 is 12, plus the extra 1/3 is 13 thirds. 169 twelfths times the reciprocal of 13 thirds. 3 is a common factor of 3 and 12, so we can reduce by dividing by 3. 13 is a factor of 169, so divide by 13. And 13 times 13 is 169. So we have 13 fourths. 13 divided by 4 gives us 3 and 1/4 yards. All right, let's start our guided practice. Number 1. So 4 and 1/4 divided by 3/4. Well, first thing we're going to do is change the mixed number into a fraction greater than 1. So 4 times 4 is 16, plus the extra 1/4 is 17 fourths. Now we want to multiply the 17 fourths by the reciprocal of 3/4. Okay, well, the 4s would simplify by dividing by 4, and that would leave me 17 thirds. 17 divided by 3 is 5 and 2/3. Number 2, 1.5 can be rewritten as 3/2, because 2 times 1 is 2, plus the extra 1/2, 3/2. 2 and 1/4, 4 times 2 is 8, plus the extra 1/4 is 9/4. Multiply the 3/2 by the reciprocal of 9/4. Okay, well, 2 is a common factor of 2 and 4. 3 is a common factor of 3 and 9. So we get 2/3. All right, so let's look at number 4. We have 4 divided by 1 and 1/8. That's the same thing as saying 4 over 1 divided by 8 times 1 is 8, plus the extra 1/8, 9/8. So to solve that, we would multiply by the reciprocal of 9/8, which is 8/9. So we get 32/9. So we'd get 3 with a remainder of 5, so 3 and 5/9. All right, number 4. 3 and 1/5. 3 and 1/5, which can be written as 16/5. 5 times 3 is 15, plus the extra 1 and 5th is 16, divided by 1 and 1/7, which can be rewritten as 8/7. So take the 16/5 and multiply by the reciprocal of 8/7, which is 7/8. Okay, 8 is a common factor of 8 and 16. So divide by 8, and we're left with 14/5. 14 divided by 5, 2, with a remainder of 4. So 2 and 4/5. Okay, number 5. Go ahead and do number 5 on a scratched piece of paper. So we have 8 1/3 divide by 2 1/2. So 8 times 3 is 24, plus the extra 1/3 is 25/3. 2 times 2 is 4, plus 1 extra 1/2, so 5/2. Multiply 25/3 by the reciprocal of 5/2, so 2/5. 5 is a common factor of 5 and 25, reduced by 5. We get 10/3. 10 divided by 3 we'd be left with 3 1/3. Okay, number 6. 15 1/3 divide by 3 5/6. Okay, 15 1/3 is the same as 46 thirds. 3 5/6 is the same as 23 sixths. So we're going to take 46 thirds and multiply by the reciprocal of 23 sixths. 3 is a common factor of 3 and 6. 23 is a common factor of 46 and 23. So 2 times 2 is 4 over 1. Our answer is 4. All right, let's move on to number 7. A sandbox has an area of 26 square feet. The length is 5.5. What is the width? Okay, so we basically are going to take 26 and divide by 5.5. 5.5 is the same as 11 halves. 5 times 2 is 10, plus the extra 1/2 is 11 halves. 2 times 26 is 52 over 11. 52 divided by 11 would give us 4 8/11. Okay, number 8. Mr. Webster is buying carpet for an exercise room in his basement. The room will have an area of 230 square feet. The width of the room is 12.5. What's the length? So I'm going to take 230 and divide by 12.5. And that'll tell us the missing dimension. 12 times 2 is 24, plus 1 more is 25 halves. All right, well, I know this ends in a 0, and this ends in a 5, so it could be divisible by 5. But I'm just curious, is 25 a factor of 230? Well, I know 8 25s is 200, so no, it's not going to be. So let's reduce by 5. Okay, so 46 and 5. Now to multiply across, 92 fifths. Take 92, divide by 5. 5 times what is close to 42? 8. And we're left with a remainder of 2, so 18 2 fifths. All right, number 9. How is dividing mixed numbers like dividing fractions? Well, after we change the mixed number to a fraction greater than 1, the process for dividing is the same, right? Okay, so once we change the mixed number into a fraction greater than 1, we just divide like we divide any other fraction. Okay. All right, so we're going to end part 1 of this video here. And in our next video, I will cover the independent practice problems from numbers 10 through 20. So until then, I'll see you soon.